So we're going to talk today about how to expand or extend your usage of JMP using open source tools like R and Python. You can actually use the same stuff that we're talking about today with SAS or CAS or MATLAB as well, but I'm going to focus on the R and Python today. So kind of some of the reasons you might be interested in this, if you don't already know why you're interested, some ideas I have about how I've seen people use these connections in effective ways are sometimes you're using special R or Python packages and you're also using JMP, and you recognize that there's a lot of stuff in JMP, especially that dynamic linkage or things about visualizations, other analytic tools that are in JMP that you might want to use, and you also still want to use R and Python things. So sometimes you might use these two things totally separately. Use JMP for some things, totally separate from using R or Python for other things. But you may also want to weave that analysis together and be able to keep one script where you're running all of those parts together and passing back and forth between R or Python and JMP. Likewise, you might be using both JMP and R or Python, and you might have a new methodology. So a lot of statisticians will put new tools into R. Some of the same stuff is happening, but more on the data science side with Python. So you might have new methodology that either you're developing and putting out there right away in R and Python that you want to compare to those validated methods that are in JMP already. And again, you could do this as two totally separate things, or you could blend it all together where you're passing the data back and forth between the packages. Or you might want to extend this even further where you're not just in a scripting language environment passing back and forth between the two software packages, but you might actually want to develop an add-in where you can make it look to other users of your add-in as though they're just within JMP and they're still using a point-and-click graphical user interface to interact with JMP as though they're in JMP, but it's actually calling R or Python or any of those other software tools in the background. So you could actually be the person that touches the R and Python code with the JMP code and blends it all together into an add-in, and then anyone you distribute that to would not have to interact with the actual code in the background. Likewise, if you're a professor and you're teaching something in your course and you want your students to be able to interact with a special package in R or Python, but you don't want to have to teach them the R or Python code, you can develop this sort of add-in environment and have your students access that R or Python code without having to actually write it themselves or adapt it themselves. So I'm going to show you sort of from a really simple, not very much coding. So the first example is actually going to be where JMP will generate the Python code for you. So it's going to start from really simple point and click, and we're going to end on simple point and click again with that making an add or the R add-in builder and making an add-in at the end. And then in the middle, we'll get into the sort of the nuts and bolts of here's how the coding is working and here's how we're blending the two kinds of software code together. I wrote a paper on this topic that you can find at this link, and I'll also make sure to give you lots of resources at the end of this PowerPoint. So there's several slides with a whole bunch of links for more help and follow-up things that you can click on. So this document, we're going to kind of go through a lot of the same examples. They're just slightly updated for this presentation. So the first example I want to show you is the easy thing that you can do with a JMP and Python connection, and that is you can actually generate some Python code. So Python scoring code for a predictive model. You can create a model in JMP, like a neural network or a bootstrap forest or a partition tree, a support vector machine. So any of our modeling types, even a regression model, or use Lasso or ElasticNet for in a regression model. And then you can generate the Python code for that. And then you can deploy that in another environment. Not only is Python code possible, but there are several other codes as well. So I'll show you this example with some housing data from St. Louis. So my colleagues have developed this. This is not something that I developed. And I'm excited to show you. We'll come to this Valentine's heart example in a second also. So here, I've downloaded this data from St. Louis. So I just downloaded these data this morning. So this is current data. The platform that I'm going to show you is built on a slightly different data set. So the model that I build right now is going to be a slightly different model because it's going to be today's data instead of the data that the original model was built on. So I've downloaded data about St. Louis housing, and I have information like the property type. Is it single family residential? Is it condo co-op? Let's actually explore a tiny bit of this data set before we build a model. So we have a distribution of price that includes a kind of long tail and high priced homes, a distribution of bedrooms, a distribution of bathrooms. You can see that some things have half baths in their descriptions, but most things have full baths listed. So we see this sort of up, down, up, down, up, down distribution. And then property type, we have condo co-ops, we have single family residential and townhomes, which I think I'll merge with condo co-ops. So I did a tiny bit of data cleaning, but this is sort of what we've got. So if we run a couple of models, and I think I saved a neural network and a bootstrap forest here. Here's a neural network, and so we can see that it allows a lot of different types of shapes in the profiler. So this is condo co-ops we're seeing have lower predicted prices than single family residential, at least for this combination of the other factors. Increasing the number of bathrooms seems to increase the price. The number of bedrooms has this weird dip in the middle. So actually higher priced homes with tiny number of bedrooms, higher priced homes with high number of bedrooms, and then a little dip in the middle. So neural networks allow that kind of a shape to be detected. So from the neural platform, from this model that I fit, I want to look for the keyword publish. And this is only available in JMP Pro, but in JMP Pro, you can publish your prediction formula to this thing called the Formula Depot. So I look for that keyword publish in order to publish the formula here. And from this Formula Depot, I can generate the Python code or C or JavaScript or SAS or SQL. So this is the easy way to just get to the code. So if I ask for generate Python code, here's the Python code that I can dump into some other application in order to deploy my model. So this is the way number one that you can connect JMP with Python is just by creating a model, looking for that keyword publish in JMP Pro, and then putting that model into the Formula Depot by publishing it to the Formula Depot, and then use the little red triangles to generate Python code. So once I've built that model, then I can deploy that somewhere else. So this is deployed on Amazon Web Services. So if I go to this link, this is what, I don't need Amazon to know my location. This is what the application will actually look like. So now I can put a marker in the particular place that the home is. So I can click in the map, and that's going to update the latitude and longitude. And I can use these sliders to update the number of bathrooms, the number of bedrooms, how long it's been listed, how much you have to pay for a homeowners association, the year it was built. So I can pick the features of a particular home that I'm looking at and the location of that home. I can click predict, and it predicts the price based on my JMP prediction model. So in the background of this Amazon Web Service application is a JMP predictive model that's predicting the housing price. So that's one really cool way that we can use JMP and Python together. Here's another just simple example. This is sort of that same idea of deploying a model. This was inspired by a Valentine's Day hackathon at our office. And so again, some of my colleagues put together this model. They're using a neural network to determine if these random points fall into this heart shape. And so then if they're in the heart shape, they get colored red. And if they're outside, they get colored blue. And then again, wrapping this just on a Amazon Web Services platform is sort of the idea. So you can generate code. Again, there's lots of options. This is actually using JavaScript code, but we can generate the Python code in this case. So that's the simplest way to use JMP with Python, is to just generate that Python code. But that only works for this sort of, you build a model, you generate the code from the model. In general, you're not really able to just generate code that's going to create that same model in Python. You're only able to generate that scoring code. So after you've developed the model, then the prediction formula is what you're able to create that code for. So to explore this a little bit more, let's look at just sort of how we could create something where we talk back and forth between Python and JMP. So in this little simple Python example, we start by opening a script window in JMP. So from within JMP, I'll clean up some of these things. We don't need to keep these guys open. And we don't even need this data set anymore. But within JMP, I can use the File New and open a brand new script window. So this is how I could start writing a new script. And with connecting to Python or R or a lot of the other things you can connect to within JMP, you're going to have to do that through our scripting language. And so you'd have to start with a script. So you start with that file open, so file, new script, and then you've got this new script window. And the first thing that I've typed into this window is names default to here. And the 1 means, yes, please make them default to here. This is just a JSL, a JMP scripting language thing that's going to help this. If I've got lots of windows open, it'll help things keep tidier and refer back to this window for me. Then the next thing that I'm typing is this Python init to initialize Python. And so what I'm typing right now is JSL, JMP scripting language code, but I'm referring to Python. So as soon as I run this line, I'm going to initialize Python. When I run this line, Python is going to be open, running quietly in the background. And there are 2 ways for me to watch what's running in the background. There are both ways to open the log. The log is what kind of helps me see what's running in the background. So one is I can right-click in the window and I can ask to show the embedded log, where it will just show it on the bottom half. The other option is to go to Window and choose the log and open the log separately. So the log will help me sort of see if things that I'm doing are working. So if I just run these 2 lines of code, I can see that it tried to run them. It echoes what I've typed up here. It tried to run both of those lines. And then it printed a 0. A 0 is a good thing. That says it ran with no errors. So far it has initialized Python. How it finds Python is it scans my computer, and it actually has a place that it goes to look for that, and you can edit that place. So if you have multiple versions of Python and you need to refer to the correct version of Python, I'll give you some links to figure out how to do that. Also, you need to have a certain version of Python, so basically 3.6 to 3.8. And I know in my case, setting this up on my Mac comes with 2.7 already installed, so I have to make sure to put the correct version of Python on my Mac before the JMP connection will work with that. Okay, so we initialize Python and probably open the log to keep an eye on this. And then we might start doing things. So again, I'm just writing in JSL right now. I haven't actually written any Python code here, but I'm just going to open a data set. So this next line is going to open the sample data set called big class. And let me actually close this little script and just open my script window. So here's my saved script. So we've run this part, and let me again click in the middle and show embedded log. So we've run this part, and now we'll open this data table. So if I run all 3 lines, it pops open this data table. Again, it's still just JSL. Then the next thing I'm going to do, so it pops open a data table. The next thing I'm going to do is send some information to Python. So again, this is a JSL command, Python send, that sends the data table to Python, and then another JSL command, Python submit, that submits some Python code. So this purple print DT, this is actually Python code referring to this new object that's now in Python called DT. So when I run those 2 guys, I see in the log that it's actually printed the data table in the log. So this is what it's doing inside of Python. And I already mentioned that we have a couple ways to view the log, and we want to be doing that because at this stage we've got some output that we want to make sure that this is actually working. And then again, we get that little 0 at the bottom just telling us no errors, everything's run so great so far. And so then I'm showing you on the slides and also on my screen the full code here with more stuff. So this Python submit statement here was really tiny, and we just put a little tiny print DT inside of this Python submit. This one is a much larger section of code. So we're doing a lot more in this next section of code. So when I need to submit a larger chunk, I can put multiple lines here, and so I can just copy and paste. You can also see these little hashtags or pound symbols. This is a comment, so this is commented out, so I can put notes to myself here, and they're not actually going to do anything when it's running. They're just lines of comment. So the lines here where I'm actually doing something, we've already done the top part. The next part in this Python submit, I'm going to ask it to print the column names. I'm going to ask it to create a new column where it applies a formula with weight divided by height, and we're going to call that pounds per inch. And then it's going to print that new data table. And so let's try that part now. So if I submit this part, again, it printed the new data table. So let's look down in the log. So it printed the column names, and then it printed the data table with this new column, pounds per inch, that we've just created in Python. Obviously, I could create this column in JMP. So I sent it out and did this in Python. That was not necessary, but it's just an example of how to pass information back and forth between JMP and Python. And then at the end, I want to get that thing back from Python. So then the next thing I do is Python get is the JSL code that's going to call back from Python what was in Python called DT and bring it back into JMP and call it DT2. And then I'll look at it as a new data table. And then I'll terminate Python to close it. So then I get back this new data table that's got my new column of variables, my new column in it. That's what I calculated over in Python. Again, I could actually have done this in JMP, but if there was something special I wanted to do in Python, I could have done that special thing and brought that back into JMP in the same way. So the idea here of this simple example is that we had some data in JMP, we sent it over to Python with Python submit, we ran some Python code on it with Python submit, and then we brought that data back into JMP with the Python get. So once we sort of pass back and forth and do all our calculations in our various pieces of software, so some stuff in JMP, some stuff in Python, passing things back and forth, then when we end up back in JMP at the end, we can use those special cool things that are just wonderful about JMP. So here I'm going to do a tiny bit more code with JSL. Instead of using JSL, I could also just point and click to do this, so I'll show you that. So we're going to get this back and then terminate Python. So here's my new data table, and then I terminated Python. And now I'm going to open this other data table, which has pictures in it, and I'm going to join this data table with the pictures back to our data table. So I can do that with a join with the tables menu and the join, or I can do it with the JSL script. So here's using the JSL script. And now I've got a new data table with the picture column joined, and I also have my pounds per inch variable that I created. So now I can do the cool JMP things, the unique JMP features like making a graph. So I could go to Graph Builder and I could put pounds per inch in the y-axis. I could put age in the x-axis. I could, let's go back to this data table and do that cool trick where we can make the picture the marker. So if I right click on picture and say use for marker, now the pictures are the actual points in the data table. So this was really easy to do in JMP. So it might have taken me quite a bit more effort in R or Python to do this. And now I could split these out by laying the sexes on top of each other. I could put regression lines instead, and this is now still interactive. So if I click on some of the points or control click to take different sections, that's all interactive with anything else I have open, including the data table. So this, what I'm showing you right now, is impossible basically in R or Python. It's really difficult to select different points without having to write a lot of code. So the sweep function is probably the closest thing in any of these packages to be able to grab some of the data and follow them across, but it's difficult to grab sort of disparate sections. So that's kind of why, even if you're a heavy Python or R user, you might want to join what you're doing with JMP, especially for this interactive stuff that you really can only find in JMP. So here's sort of the point. We can pass things back and forth, and then we can use special things in R and Python that aren't available in JMP, and we can use special things in JMP that aren't available in Python. Okay, so we can do the same thing with R. And if you need help on the specifics of this, there's a lot of help available. I'll show you a bunch of resources at the end of this webinar, but one place to go right away is the help in JMP and the scripting index. If I go to the help menu and to the scripting index, there's a searchable section here. I could just type to search, or I could scroll down and find, for example, the section on Python. So here's Python and there's R. If I click on the Python, this is all of the special Python commands. So these are JSL commands that will do things with Python. It gives you little examples here, and you can actually click the button and just run the example. and then it'll show you in the log below what is happening. You can click on the topic help button to go directly to the help, and then the C also sometimes has some similar things to help you. So the scripting index is definitely going to be helpful as you're needing to learn a little bit of our JSL to use this connection. So a simple example of this with R, same idea. We open a script window, we use JSL to refer to a data table. So for example, I can open this fitness data table in JMP, or this commented outline. If I have a data table already open, I can just call it current data table. That's the JSL to refer to the open data table instead of having to point to something. This, in using R, it's easier to send things as a matrix, or at least with my use of R, I prefer to send things as a matrix. So I'm opening the data table fitness, I'm sending it as a matrix over to JMP or to R. So then I initialize R, I send that matrix over to R, and then I'm going to do something. I'm going to specifically take the 6th column, so the 1, 2, 3, 4, 5, 6, the runtime column, and I'm going to take the log of that column. I'm going to call that the R log runtime column. And then I'm going to make a histogram of that. So this is all R code that's in purple here. And then I'm going to print the matrix of the new data table that's got that extra column in it. So I'm going to print that DT matrix column. So that's going to happen in the log. So this is all R code that I'm going to use, and then I'll start bringing things back. So let's try this example. Let me close off our Python example. And I'm going to use this simple R script. So I could uncomment this and refer to a current data table if I had one open, or I can ask using, I'll say names default to here to make this tidy, and then I will open this fitness data set, which is a sample data set. Then I can make it into a matrix internally in JMP's memory. Then I can initialize R and send the matrix to R, and then I can create that log of runtime column, make a histogram of that. So let's do all of those pieces together. So it created the histogram in R. There are lots of ways in R to make this prettier. This is just the basic, simple histogram. So I could put R code to make a prettier version of this. There are things I could do, but if I want that interactivity that's available only in JMP, then I'd want to bring the data back and make that histogram in JMP. So again, I'll print this, and I'll right-click Show Embedded Log so that we can see. Let me run this part again. So we see it. So it printed the data table, and you can see the data table has, so this is our data table. And then to bring the results from R back into JMP, I'm going to bring a variable I'm going to call JMP log runtime by using the JSL command rget to get this back from R. This is the thing I'm bringing back from R. That's its name within R. So when I do this, it's going to bring it back into memory in JMP. But then I want to dump it into a table. So I'm going to actually use this to set the values of a column in this new data table. So let's do all of this. So now I have a new data table in JMP with the column of those log values. So now I could make the distribution in JMP, either using the code like this, or I could do it the typical way, going to analyze and distribution of this guy and saying, okay. If I want to save this code and not have to learn to write it myself, I can do that by right-clicking at the top and say Save Script to Script Window, for example. And so that's how I can easily cheat and grab the code without having to learn how to write it myself necessarily. So if you're a JSL programmer, wonderful. But for those of you who are not seriously into JSL, our JMP scripting language, you can still use this R Python connection with just a minimal amount of JSL. So if you did want to add things like this distribution, you can just grab it by copying that save script to data table or to script window. So now, again, I've got that special feature in JMP where I can choose different regions and have that highlighted in the data table, and I just interact with it so much more easily than I can do in R or in Python. So using JMP features that are really unique to JMP, but also being able to do things in R or Python that I might want to do. Okay, so I'm going to switch over to sort of showing you why in a bigger scheme you might want to use this. So what could you create by doing this? So this was sort of the mechanism of how it works, but there's a lot of functionality you can get going further with this. So here's a really nice example created by my colleague MJ Guan. He's a developer on the JMP Genomics software, and he was using this T-SNE and UMAP methods of visualization of sort of clustering data. So you get different clusters and you want ways of visualizing them in 2 dimensions on a screen that that will help you sort of understand where the clusters are. This T-SNE, that T stochastic neighbor embedding, and this UMAP, these are 2 methods of displaying that cluster information onto a 2-dimension plot. So you can download this add-in, and I'll show you where this is. So this link here. So on our community, which is community.jump.com, there are tons of these add-ins. Some of these add-ins are using R or Python or other software connections. And so this is a really nice example of using that connection. This add-in is built with the connection to Python and the connection to R. So you can use these methods from either version. So if you've only got one of them installed and you prefer to use either Python or R, you can still download this add-in and use it with either. So the idea here is you're going to create these visualizations. So this is the T-SNE visualization at the top. This is the UMAP visualization at the bottom. And JMP, this is April of 2020. JMP does not currently have an implementation of the T-SNE or the UMAP method of visualizing these clusters built directly into the software. So using this add-in allows you to take advantage of things that are in R that aren't available in JMP, but you can still interact with it in that sort of clicking on points and visualizing them in other plots at the same time, some of those tools that are really cool in JMP. So to download and use this from this website, we would look for this add-in at the top. So something that's turned into a JMP add-in is going to have this .jump add-in extension, and we would just download it. So if I click on this, it downloads it. And I've already saved it over here in our examples. So when I download it, it comes to my computer with this .jump add-in extension. When I have it this way, if I double click on it, I can say, should I install it? It's asking me to reinstall because I already have it installed. So I'll say cancel, but you would typically say install, and then it would very quickly install it into your machine. So then in your JMP menu, the add-ins will show you. So here's where that is. Will show you all of the add-ins that you've installed. So I'm good, mine's already installed. But if I want to explore what's built inside of it, then what I need to do is change this JMP add-in to .zip instead of .jump add-in, as I've done below. So when I do this, it's going to make me the zipped file, and then I unzip it. When I unzip it, I'll see these 2 things happen. And so here's what's actually inside of that add-in. There's a bunch of scripts. So here's a script for about the add-in. So if I open this, this is all the information that's going to show up in about the add-in. So let's look at the add-in embedding. Here's the about. And so all of this text, all of that information, this is what it looks like in JSL. So what I'm doing, or what MJ did to create this, is we're making some script files that have the various components that we want for our add-in. So there's a whole bunch of, here's where our initializing is, here's where we're doing a bunch of things with our code. And we're able to then package it up in an add-in. So here's how we would use this particular add-in. If we're in JMP, and we go to the embedding add-in, let me open the sample data table. And this data table it has the labels of the correct answer, and it has, each row is all of the pixels that make up a digit. So it's a handwriting sample. So if you imagine where someone has written the number 1, so this one, the label is the number 1. So where someone has written the number 1, we're taking that box around it. So imagine this to be like a perfect square. And I'm not able to, let's try changing it like this. So imagine sort of a perfect square around where the digit 1 is, and we divide that up into a bunch of pixels. So the row is describing all the pixels for that square, and we're the zeros and ones are, is that pixel filled with color or not for that handwriting sample. So this is a whole bunch of information, pixel information for this was a number 1 that was written. This is a number 0 that was written. This is a number 1 that was written. So we want to be able to correctly identify those digits. So we're going to use the pixel information to try to capture those clusters and figure out those 9 digits, 10 digits, 10 digits. So from the add-in, I would go to embedding, run the embedding add-in, and this is what MJ was able to create. It looks like I'm using JMP. So making an add-in in JMP allows you to make these column selectors and put things, so I can click the label into the label. I can grab all the predictors and put them into the predictors. So I'm going to use the pixel information, the 783 pixels, to predict which cluster we're in, and then we'll see if they're correct by the labels. So here I can either use the T-SNE, or I can use the UMAP, or I can use both. And if I click the Run button, it feels like I'm just using JMP, but actually the add-in is calling out to R. And so because I've already got R installed on my machine, you can see it down here. And because I've already installed the correct T-SNE and UMAP packages within R, then I'm able from JMP to call out to R behind the scenes, run this in R behind the scenes, and then bring the data, the results back into JMP to visualize them in JMP. So this might take a second longer. And I get a little warning because I think this was developed on Windows, and I think I have a font on my machine that isn't available where MJ developed it. So no problem. This is what the final result looks like. So each point here was one of those rows. It tells me this was row 2285, and this was a number 1. So this guy just had a funny handwriting. The number 1 didn't cluster as well with the other number 1s. Here's the rest of the number 1s. So most of the number 1s cluster nicely together, but some number 1s look a little bit like other people's other digits. So like here's the 5s. So this number 1 apparently looked a little bit like a 5. It clusters more closely to the 5s. Some of the numbers that are kind of similar in shape, like the 4 and the 9, are quite similar. So here's the 4 and here's the 9. And you can see from this visualization, it's a way to take those clusters and put them into two-dimensional space to help us understand what are similar to each other. And we can see that here. The 4 and the 9 are quite similar. 9 kind of divides right down the middle of the general area where the 4s are. We see some 4s also overlapping with these guys. These are the 6s. So apparently some of the 4s and got sort of tied up with some of the 6s. So somebody's 4s looked a little bit like 6s. So that's the idea, is that you take R code or Python code and kind of hide it inside of an add-in so that other people can use this cool add-in from JMP and feel like they're using JMP, but actually it's calling out to R or Python. So if you want to do this without having to write all of that code yourself, all of the JSL, if you just want to use your R or Python code and dump it in and create something, there is actually a really cool tool that was developed by a woman named Julia Gong when she was a high school student. She was a rising senior a few summers ago, and she did an internship for JMP, and she built this really cool add-in. So with this add-in called the JMP-to-R add-in builder, you can dump your R code into a section and you can build out your own add-in without having to write the JSL. So I promised you at the beginning we'd start with that. You don't have to write the Python, we give it to you. And we'd end with, you don't have to write the JSL, you just dump your R code in. So this is the easier way to create this sort of a thing. So this is a really cool place to go. So if you click on this link, this is the JMP-to-R add-in builder. And I'm showing you what we're doing right now on a Mac. This unfortunately only runs on Windows, and also the 2 add-ins that she created to demonstrate this also only run on Windows. So instead of showing you this live, I'll show you this in some slides, but it's a really cool add-in. And if you would like to make this work for Mac, we would love that. This community is an open community, and you can post the cool things that you make here. You can download other people's cool things that they've made. You can ask questions in our community. You can answer questions in our community. So if you want to grab this add-in, so here it is, the JMP-to-R add-in builder .jump add-in, or with an extra report feature added. If you download this, save it to your computer, and then where you've saved it, if you change that file extension to .zip, then you can open it and look at the internal mechanisms, and you could try to fix it so that it runs on Mac. So if you want to do that, a lot of people would really love that. So the idea here is you want to create some kind of add-in like we just saw, but you don't want to have to write the JSL. So Julia wrote the JSL already for you, and she just made this a lot easier. So as an example, if our goal was to make an add-in to run a support vector machine, this is the example that Julia uses on this page. You don't actually need to use R or Python for a support vector machine because that's built into JMP now. JMP 15 has support vector machines. But again, if we wanted to call out to something else like support vector machines in R, this add-in would help us to do that. So our goal here is to refer to some columns like the cell size, nucleus, mitosis, and the class that these belong to, and then to actually make those predictions using a support vector machine. So we're going to make each of these components in this add-in as inputs. Then we're going to dump in some R code that takes those inputs and does stuff in R and gets the SVM predictions. And then our results that we'll bring back will be this classification plot. And then a column will get appended to the data table saying what those predictions are. And then we'll get the cross tabulation of the, here's a false positives and false negatives versus the correctly classified negatives and positives. So if that's our goal, creating this, Julia's add-in allows us to start with 10 steps to build this add-in. So we first have to have in mind what we're trying to create, which is down here. And the first question is, how many components should your add-in have? So in this case, we're going to have 6 components. We're going to have this first column selector component. Then we're going to have this choosing the support vector machine type, if it's classification or if it's something continuous. Then we're going to have the format for the prediction column. Then we're going to have this selector for which column is the factor, which one should be the y-axis, which should be the x-axis. So that's a total of 6 components that we're going to put in this add-in. And here's the first column of the add-in and the second column of the add-in. The second column is tricky. This action buttons, they're just always stuck onto the second column. So this is actually 2 columns that we're trying to build in this add-in. So then step 2, for each of those components, what type of component do we want? So this one, the select columns, this is a column list component. The next component is a drop-down menu, then another drop-down menu, then a column selector, another column select, and another column select. So we have all of these options. Numeric value we didn't show, but you would just type in a value if it was a numeric value option. Then the third step is to specify, okay, in the first column, these are the 3 components I want to put in the first column. And for things that are a drop-down menu, I have to give it a title and give it all of the drop-down options also. So C classification was the option that's showing, EPS regression is the option that's not showing in this picture, and SVM type was the title. For the second drop-down menu here, prediction column format is the title. Then numeric is the first drop-down option, character is the second drop-down option. So we specify the name, and then each drop-down option, name, drop-down options. Everything is required as well from the column selector. So these guys go in column 2. So we have the first 3 things going in column 1, the second 3 things going in column 2, and then we have those titles and text for some of them. In step 4, now we name the titles for those column 2 options. So the column select 1 is called factor, then y-axis for the plot and x-axis for the plot. Step 5 shows us a preview of what we've created so far. Awesome, that looks like what we want it to look like. Step 6 is where we can name our add-in and give a little description of our add-in. And then steps 7 through 10 are all about your R code. So we're going to try to put this R code into this add-in. So this is going to send some things. It's going to send SVM type and factor and yvar and xvar and yvar. So these are some of the inputs that are going into our R code. And it's going to bring back the pred and the pred table. So here we have to name our input variables, that the same names that we used on that R code a second ago. So those names in blue, we need to name those guys here. And then we also have to name the things we're bringing back from R. And then we can dump the R code, just copy and paste it into this box. Then we have to, in step 9, talk about the 3 pieces of output that we want. So one of them is going to append this predictions into a column. The second one is going to open a new table with this cross tabulation. And the third one is going to open this R plot with the predictions. The very last thing is a little bit more about those predictions and what their names are, and saving the plot in a JPEG. And then it all packages it right up into an add-in for you, and other people can install that. So that if you're going to make an add-in out of something where you're using this R or Python connection, if you want something with R code on Windows, that is a really cool tool to help you not have to write all the JSL code yourself. So that was a whole bunch of examples. I went kind of quickly, so hopefully if you have questions, we can go back to those sections if you want to explore some of that in more detail. But I know there's no way for you to walk away from this webinar just knowing everything you need to know about how to write stuff in JSL, how to connect properly to R and Python. So I think one of the most important things I can point you to is all the resources about this stuff. So that making an add-in, you may be using your R and Python connection to jump without an add-in, but most of the use cases that I've seen folks use, it's really nice to package it up at the end as an add-in. So if you do want to do that and you need to learn how to do that part of it, there's a nice one-page guide. So if you go to this link here, you'll see this add-in builder. And it has a little video link and a one-page guide link. The one-page guide just gives you one page that walks you through how to do this. So how do you name it? Where do you go to open it? Where do you dump the code? And then the corresponding video shows you this in a video instead. So the video is just under 4 minutes, and it's a very nice way to learn how to make an add-in. More links to help. So there's a lot more examples of that, all of these things for Python and for R. So if you go to this link, this is just examples in general for R and for Python. All of the sub pages of that are the specific help as well, but I'm going to point to a few specifics. So also if you did want to do more of that code generation, so creating the Python scoring code, this help link here will tell you a little bit more about that. If you're trying to get Python correctly installed so that JMP is calling the correct version of Python, you can get some help here at these 2 sites. So the first one about installing Python and then about troubleshooting that integration. If you're doing that for R, you can go here, how to install R. And I'll tell you a couple things I've learned by installing R and Python on my Mac. One of those things is that you need R version 3.3.3 or earlier if you're using Mac. There is a support note about this that it hangs up if you've got something later than that. So that's no problem. If you have multiple installations of R on your computer, that's also fine, but you do have to make sure that you've got JMP calling the correct one. So all of that information is here. So let me just show you what this page looks like. So this help on installing R tells you where you can download R, and because JMP is 64-bit, you need to make sure you're getting 64-bit R. If you have any issues with which version of R JMP is calling, there's some tips on how to do that in the Windows system to check the environment variables, and it talks about how JMP looks for what your R installation where it is. For me, this was really easy. I have only one installation of R, so there were no issues for me. I just installed R 3.3.3 and I never had a problem. To test the setup, you can do that R init and check your log. Let's look also really quickly at some of the instructions about I think maybe the second link. Nope, that's not going to help me either. So this troubleshooting link should take us to the page that describes the versions you need. And for Mac, 3.8 worked really well for me for Python. My Mac automatically has version 2.7 on it, so that actually I did have to go through some effort to point JMP to the correct version of my Python to get that to work. So hopefully those tips are a little helpful. The setup could be super easy. For me, the setup for R was really easy and the setup for Python was pretty complicated. So it depends on your configuration, but those help links should be really useful. And then when you're using JMP with R and Python, so I think There's a few more links that might help as well. This is the link directly to that paper that I wrote about this that's got some examples built in it, and I kind of followed that for this webinar today. Here's a link to the JMP-to-R add-in builder, and also that SVM add-in is there. Remember, this only works on Windows, so that if you want to build that JMP-to-R add-in builder for Mac, we would love that, but right now it only works for Windows. And then the T-SNE and UMAP, if you want to see that add-in, download that and use that add-in or explore how it was built, that's at this link. Whoops. And how to make an add-in, again, is at this link. So I gave you a ton of examples, a ton of resources, and I think you're going to find yourself with some questions as you get started. So if any of you are on and you've tried any of this before and you'd like to ask me questions, this is a great time for me to see if I can give you some help on how this connection works. Yeah, so I did find that to be kind of tricky for me. So for Mac, for me on a Mac, you need version 3.3.3 or earlier if you're using R on a Mac. I think any version of R should be fine on Windows, but on a Mac, 3.3.3 or earlier. And Python on either Mac or PC, 3.6 to 3.8, I think, or Anaconda, the versions of that are listed again at one of those help links here. Yeah, so as I mentioned really briefly right at the beginning, there are other connections besides just R and Python. R and Python are great because they're free software, so anyone can be installing these, but SAS is also, so JMP and SAS are the same company, and we're able to really integrate very closely with SAS because we're the same company. So that Formula Depot stuff that I showed you at the very beginning, so when we're in JMP and we run something like a predictive model, and then we save out using that publish prediction formula, it saves it into this thing called the Formula Depot. And from this Formula Depot, we have the ability to generate SAS code here. Again, these are the scoring codes. You can actually also generate the actual SAS code from a few types of models, like a time series model, or if you're using fit model. So there are other SAS connection things. Those you can learn more about from, if you go to our jmp.com/teach page. There's a bunch of resources down here, and this learning library, so the webinar library is here, the learning library is here, which has these short videos. So there's a whole section on SAS from JMP. So if you want to learn more about the SAS connection, there's lots of information on that. MATLAB can also be connected using our scripting language like Python and R, and the CAS, Cloud Analytics Services statements that SAS Via is using, can also be linked with JMP. Yes, so this can be really helpful as you're learning to create these things, to look at other people's examples. So if you are able to download something from our JMP user community, which you can get to from any JMP page, or you can go directly to community.jmp.com. We have, you can search just all add-ins if you want to. So here's 919 posts about add-ins. So lots of different add-ins that you could be downloading. So from any of these add-ins, some people will be encrypting their add-in, so you won't be able to look at the internal mechanism of every add-in, but a lot of users will post their add-in just as is, sort of. And so when you download the add-in, like we did for this embedding, when you download the add-in, it first downloads with a .add-in extension, and then you change that extension to a .zip, and then unzip it. And when you unzip it, then you can see all of the internal mechanisms, all of the scripts that get called, and so on. Yeah, I don't think I have particularly great advice. So I was in grad school about 15 years ago, and there weren't as many great options when I was learning these things as there are now. So probably just Google searching learn Python or learn R, you're going to find a lot of resources. There's certainly like a lot of stuff on Coursera and other of those sort of websites, Lynda, those systems. I bet there's Khan Academy, or there's tons of YouTube channels now that do sort of simple learning tools for these kinds of things. If you are a JMP user and you are happy in JMP, there's not an R or Python package that you need. Honestly, I don't think you need to be going to learn in R and Python. The reason that you'd want to be using these connections or using a scripting language is to extend what you're already doing from a nice point-and-click user interface. So there's so much built into JMP already that you can just use from point-and-click. But if you want to extend that further, if you want to be able to write your own scripts, then learning about our scripting language, JSL, or learning about the Python and R scripting languages, there's a lot of resources online. And I don't know if I pulled this up, but if you wanted to learn more about JSL, again, that scripting index in the help menu and then scripting index has our commands and little snippets that you can cut and paste, but also lots of other resources about learning JSL. So if you go to jmp.com, at the top, there's a Learn JMP tab. So if I go back to jmp.com, there's a Learn JMP tab, and there's this Mastering JMP series of videos, lots of stuff here, and there's some JSL specific videos there. You can also get training through the SAS education group. If you have an academic JMP campus license, so if your university is using JMP through a JMP academic license, you can send us an email at academic.jmp.com if you're a professor and you want to get access to those e-learning courses for free. So there's, you can, if you're from a corporation, you can be purchasing training. I think there's actually a few free training courses right now in April of 2020, so you can contact SAS Education to see what's available. But there are some nice e-learning courses about JSL. Also, you can post your questions in community.jmp.com. So if you're trying to write something in JSL and you're stuck, lots of people use our community to ask and answer questions. And there's a nice little blog here on the community about what resources are there available to learn the JSL scripting language. So again, I'm just kind of pointing you to some of these things as well. So thanks everyone, we appreciate your time.